sticking to geometry this week. Think I might do another day of triangles and stuff. Then I might go into some other shapes starting tomorrow or maybe Wednesday. So I guess I want to start now. So we have a line with a triangle sitting on top of it. All it wants to know is what is the measurement of that angle, the one right there at the top that I circled. So this stuff is extremely simple. The way we get to it is, one thing you got to know about all triangles, if you add up all three angles, this angle plus that angle plus that angle, and we're talking about the interior angles, it should give you a total of 180. And we also know that when you sit something right on top of a line, the line itself is a total of 180 degrees. So that's going to be the first rule that you got to understand and know to attack this problem. So if we want to find this missing angle, right, what I have to do is, remember, we know we have a total of 180 degrees, but if I take away the 88 degrees, what I get is 92. So that means this has to be 92 degrees. Those two together would give you 180. All right, so I figured out my first angle. All right, so I come right over here and I do the same thing. Remember, over here, I know I have 180 total, but I have to take away the 140, and that leaves me with 40 degrees. So this angle is 40 degrees. Remember, those two together give you 180. Now I have enough information inside of my triangle to figure out the missing angle. And just like a line, all three angles, interior angles on a triangle is 180 degrees. So basically, I just got to add these two up, which I did right there. I got 132 degrees. And to figure out the missing angle, I need to take the 132 away from 180. So there's my 180 minus 132. It leaves me with 48 degrees. That means my angle measurement here is 48 degrees. Angle B is 48 degrees. End of the problem. All right, so let's break this whole thing down. We had to figure out the measure of angle B. We had to get these two first by using what we knew about what we call these are linear pairs. A pair that's two angles to form one line, right? That's a linear pair. So if I subtract if I subtract 88 from 180, it leaves me with 92. That gives me my first linear pair. If I subtract 140 from the 180, that gives me my second linear pair. If I add these two up, subtract that from 180, it'll give me the number that I'm left with up here. So these problems may seem difficult, but if you think about the steps that it took to get there, where this is a high school type of problem, this is a type of problem that you can see on standardized tests. In essence, the only thing you need to know how to do to get this problem is add and subtract. What makes it hard is that the definitions are what you need to know to get to or know what to do to solve the problem. If you know your definitions and what they state and what those definitions really mean, none of this stuff is as difficult as it seems. One of the main things that helps with a problem like this is if you actually practice drawing diagrams using a protractor. If you use a protractor, it kind of forces you to make your calculations as you draw. And when you start doing that, you start noticing how the numbers do add up. If you use a protractor, you'll notice that on your linear pairs, you will get the 180 every single time. You'll notice also within your triangles, you'll get 180 degrees every single time. So the more you're familiar with actually doing those or building your own or constructing your own diagrams, it makes the numbers easier to deal with. So I took this problem that we just did on the board and I threw it into my software that I use. I like using this software called GeoGebra Classic 5. They have other versions, but version 5 is like my favorite one, where you can actually see that I can literally move these around and you can see the numbers change. And as the numbers change, you can play around with them and start to see if you can start figuring out those missing angles similar to what we just did. So like right there, I just switched it up. And then with that one, it'll give me what the measurement is up here. The goal with this type of problem or this software or this one that I just designed is that it'll be up to you to figure out these two angles yourself to get to this angle. Once you do that on paper, you can come up here and check it. And the possibilities here are unlimited because the more you drag them around, it's like you're getting a new problem every single time. So it's kind of cool. Like, not only can I move this line around and drag it anywhere I want it to go, I can take this point and move it wherever I want it to go also. So I can do a lot with this type of problem right there on the fly, real quick, and the numbers calculate as I go.